All right, so today we have Gev Sogomonian. He is the co-author of AimStack, which is an open source project, which is described to be an easy to use and supercharged open source experiment tracker. So Gev, welcome to the Data Exchange podcast.
Thank you. Really excited to be here.
So one of the reasons I have you here today, and this is just one of the topics we'll talk about, is a new integration that you guys have with MLflow, which has a great name, by the way, AimFlow. I guess that's the right. I guess that's the right pronunciation, right? So, but before we get into that, so very quickly, so was my description of AIM correct? It's a supercharged. It's basically an open source experiment tracker.
Yeah. So essentially, we are we always think about machine learning metadata, and we have started building this project as a machine learning metadata tool. And what we have ended up doing, we have ended up building a UI on top of it that made it an experiment tracker. So for us, experiment tracker is a metadata application. But right now, a lot of people use it as a experiment tracker, but there's layers and underneath AIM. So it's more of a metadata tool than just an experiment tracker.
So, of course, listeners to this podcast are familiar with other experiment trackers. I mean, MLflow is an experiment tracker to a large extent, but there's also the commercial ones. So why was it important for you guys to be open source?
Right. Well, for us, we are, myself and my co-founder, Gore, we have been building infrastructure for the last, 10 years. So this involved like microservices, lots of JavaScript stuff, right? For us, the DNA of infrastructure must be open source. All of our favorite tools like Apache Spark, Ray, I don't know, the Apache Kafka, right? They are all open source. And so it's been basically a kind of a no-brainer to think about this problem as an open source problem.
So historically, as you mentioned earlier, you came at this from metadata, right? So gathering metadata, and then, so how did the experiment tracker come about?
Yeah, so I guess it makes sense to share a little bit the pretext about the metadata. So fundamentally, the way we have been always thinking about this, software 1.0, software 2.0, right? The difference is that, hey, when you're dealing with the regular software, you can read the code and you can change the code and you can deploy the code. So kind of the code is the source of the truth, right? You can think about it. You can, can make mistakes there, right? But when it comes to the software 2.0, the end result is the model, which is basically a bunch of numbers. So how do you think about it? How do you reason about it? And plus, this whole process that it has to go through is very stochastic. Everything it touches is iterative, right? So it naturally has brought us to this idea, how can we build a tool that can track everything about these, models or everything that makes them, happen, right? Including the code, which we kind of consider as a form of a metadata, because there's a code, the data, you change the code, the model changes, right? Everything is about the model. So that's how we have started about thinking about this problem.
And historically, when you started, I'm assuming there were experiment trackers.
Of course. But the best, if you build a storage that tracks a ton of metadata, one way to so experiment tracking is a very straightforward application of this type of a project. And so and especially that if you look at the open source experiment tracking tools, especially when it comes to some of the UI aspects of things, there's lots of functionality that folks would love to have, right? On top of if you can track a lot of metadata, you need to be able to really heavily manipulate it with the UI. And this has basically motivated us to, hey, what about we try to really build this UI on top of this storage that we have kind of created, and give it to the users and start working with them and then see where it goes. But the original idea for us is machine learning metadata. We believe it's a key component of the infrastructure, like centralized way of tracking a lot of this metadata, to that we want to build, and we are trying to do.
So the people who use AIM today, so in order to do this well, you have to have integrations with many things, right? Because machine learning, as people know, is a pipeline, and each stage of the pipeline, there might be 50 choices of tools.
Yeah.
Right. So how do you go about making sure you have the right integrations?
In terms of with the right tools, or
yeah.
Well, this is very community driven for us, right? We work with quite a lot of teams who use certain tools, and so basically all of the integrations we have right now are one way or another requests, or in some cases demands by the tool. For instance, the integration with Ray is a community, like somebody from our community have gone and opened the PR. So, and good number of others are like that too.
And so basically right now, pretty much any common machine learning library you guys can work with.
There are a few that are very C++ heavy that we haven't gone into that yet. But
for example, Gev, I'm thinking in the area of time series and NLP, each of those has many libraries, right?
I'd say so.
Yeah.
Like we have one with Spacey, we obviously have with Hugging Face. So yeah, whenever we see one of our users, like if there's like a critical kind of group of the users who are using certain tool and they need some kind of an integration, we either add it ourselves or we help the users out themselves. Yeah, and some of them are actually even on our end, the integration. So yeah, as long as the users are easy to use.
By the way, it's interesting you talk about metadata, because metadata itself is a topic that became popular among data engineers and data infrastructure people for different reasons, right? So for data discovery, data governance, data catalogs, and things like that. So in your case, so how do you store the metadata?
So basically, the way we have been thinking about this is a lot of the machine learning, applications are multi-write, like very high frequency. And so when we were, starting to think about this problem, another kind of constraint we had was, well, how can we make it very seamless to use? Which means if you install our library, you're not going to deal with any type of background work, service, install a database, etc. So the magic library that basically saves any object you throw at it kind of magically. And so we have done quite a bit of research, and we ended up using basically adopting this RocksDB based kind of storage and building a layer on top of it that encodes data and decodes in a certain way. And most importantly, it enables this Pythonic query interface. So basically, imagine you're querying several thousand machine learning runs, and obviously each of them have maybe several hundred hyperparameters, like lots of metrics, lots of images. How do you, and lots of dimensions, right? How do you query them in a easy fashion, both on the UI and maybe on the code side to do all sorts of things? So we have enabled this Pythonic interface. You essentially end up writing an if statement over everything you have tracked. So if you have say you have tracked a learning rate, you can say, oh, give me all the, and this is a very old basic one. You can write full-fledged Python statements that you say, oh, give me all the runs where the context is equal, give me all the metrics where the context is equal this, like a test, and then learning rate is greater than this when something. So you can
So this is your own kind of Python-based query language, or can someone write something similar to SQL?
We have decided to do Python because it's basically the default language for data science / MLOps.
Yeah. So, most ML people may not know SQL, right? So
There is a chance. There is a chance.
So by the way,
Yeah.
my friend Dhruva, who's the creator of RockCB, will be happy about this, right?
Yeah, I would love to chat.
Nowadays, of course, I guess it depends on how much data you have, but one can imagine also throwing this thing into SQLite or DuckDB, right?
We have had a few pushes for DuckDB. We are still it's a whole like a quite
But
a large task
it's in memory, and then I don't know exactly how it will be if many people are hitting it at the same time, concurrency and things like that, right?
That's a good question. So when it comes to concurrency, we don't have one RocksDB. It's the layer that has a bunch of different RocksDBs like per one. So you can easily, it's as concurrent. Like we have folks, to give you an idea, we have folks who train large language models using AIM, like on a distributed environment. And there are folks who run like lots of simultaneous training runs on like Kubernetes or Ray type environments as well.
One of the things you've done is besides collecting this metadata and exposing it to people so that they can run queries and stuff, is you have a nice user interface. And in fact,
thank you.
That's one of the things that you guys have added to MLflow, right? So talk to me a little bit about what's the origin story of AimFlow.
Sure. So basically, there have been quite a number of folks that we were talking to that were using MLflow, and obviously we are like huge fans of MLflow, right?
Oh yeah,
so
it's the most popular. By the way, I did a deep dive into the space, and MLflow and TensorBoard are by far the most popular tools in this space.
Oh yeah,
yeah.
Oh yeah. So, but MLflow is this amazing, end-to-end machine learning kind of infrastructure kind of platform, right? Where you can do a lot of other things like model registry, deployment, etc. Right? So, and we see people use it in pretty full-fledged. But we have seen, and so therefore it has like so much capabilities. But we have seen a lot of people have been coming to us like saying, hey, how can we use this together? And actually, we had a user who had kind of put together a way to query MLflow data and put it into AIM, so they can also observe. And it was like, oh, great, let's maybe potentially build this project where we can not only just query, but like sync those, to metadata, so that it's very seamless. You keep using MLflow, but you can then easily basically sync our metadata storage with MLflow's data storage for experiment tracking, and just have AIM use along with it pretty seamlessly. Just a few, not even a code change. But also on top of that, if for instance down the line you want to use like images or text or other types of like audio, so AIM is already there. You can like easily use AIM API as well. But so for us it was a no-brainer. How about we build this best of both worlds?
What do you mean? So what do you mean when down the road when you want to use images? You mean when you want to start building computer vision models?
Yeah, obviously not a lot of MLflow users are maybe doing that type of stuff, but maybe text. So we are more like broader focused on metadata. So it would be like it's kind of nice, help a superpower on top of what MLflow does. So this is how we look at it.
And so right now, if you were, I don't know if you folks have done this, but if you were to do a survey of AIM users, so how would you break them down in terms of profiles? Are they mostly ML engineers, data scientists? So who's using AIM right now?
A lot of scientists, obviously, because it's an experiment tracking interface has attracted a lot of scientists. But in the last few months, we have been seeing a lot of MLOps engineers too. And especially they are building lots of automations on top of the tracked metadata. And this is kind of the original reason we had built AIM for. And so this new major version is going to even enable ways to not just build on top of this, but combine a lot of this, metadata pieces into this larger thing, called AI metadata infrastructure.
So in terms of the user interface for listeners who are not familiar with AIM, so what are some of the common ways people interact with AIM using the user interface?
So these views that we have created called explorers are essentially ways to compare like lots of these multidimensional metadata. For instance, metrics, right? When you have maybe 1,000 training runs, and each training run has several hundred metrics, and you want to extract insights from all of these runs. So what you end up doing is to somehow basically comparing these metrics. And so what the explorers do, they allow to search using this Pythonic search a lot of these metrics and heavily manipulate them, group them, add lots of different, say make x-axis another metric. Basically, these are full-fledged comparison views that we have not only for metrics, but for images, for audio, for we actually even have abstracted away this explorer into something called base explorer that can compare any kind of metadata down the line.
So when you think about ML experiments, right? So people do these runs, they get the results, and they want to understand the results, but sometimes that requires going, understanding the data, right? So doing some kind of deep dive into data quality or things like that. So are all of those available through this interface? You can do kind of a root cause. So here's the metrics. Now I want to trace back and figure out what's causing the model to behave this way.
Yeah. As long as you track it, you track the data, the more you track, this is another ethos, right? The more you track, the more you need to track as much as possible, right, to be able to see those insights. But yeah, as long as you track it, you're going to be able to compare all of these data together, like query them, chop them with, group them via hyperparameter value, or basically group them, divide them into charge, combine them back, it's a lot of extensive operations across the board for lots of different, for images, for metrics, for audio, for sweep type, hyperparameter tuning situations. So it's
so in terms of again, going back to usage, so what is it? Mostly deep learning? Is it mostly structured data? Is it mostly computer vision? So what's the current usage profile of AIM breakdown?
So we first, to be honest, we've seen basically all, from all circles of machine learning people.
You're not collecting logs or metrics of usage.
We have an opt-out UI kind of on the UI.
So what are you seeing from these usage metrics?
It's just everybody uses explorers, right? Everybody uses explorers. So these are obviously anonymous, so we don't know. But everybody uses explorers, and we talk a lot with the users, so we know quite a good number of them how they're using the SDK. But right now, the researchers, and that's the end user for these UIs, are we have quite a bit of like a core group of NLP folks, visual, computer vision folks. Oh, but by the way, one of the ways AIM have got battle tested is the reinforcement learning researchers. So that's when we realized the numbers was like, oh my God, you track like 1,000 experiments per week, each experiment several hundred metrics. That's a lot.
RL, right? So I hope they're using RL-lib.
Oh yeah, I hope too.
So right now, AIM, would you say AIM, most users of AIM are using it for developing models and prototyping. So you're kind of early in the ML pipeline, where I'm still kind of figuring out what model I should have, right?
Yeah. So you run lots of these experiments, you track them, this information about them, the metadata, sequential data, and then use the UI to visually see insights, like understand the best model or the best experiment that created the model. And on the MLOps end, folks use the API to build lots of automation. So for instance, we have recently launched this feature called callbacks, which is essentially a surgical way to intervene within the training run. You can, I'd say, almost literally create heuristics about your training. Say, for instance, you can actually create like a whole function logics of saying, oh, on the aggregate value of this metric, when some certain formula works is true, then behave this way. For instance, turn off the run or send a notification. So we have seen a lot of people use actually save a lot of money over GPU utilization using these features. And these are unique features in terms of, because it actually very surgically intervenes into the run. You can program per iteration value of a metric in that fashion. So
yeah, because there's especially in the deep learning world, there's a lot of heuristics and kind of knowledge that gets passed on almost orally from within a group, right?
Yeah, so you can now, with this feature, you can actually have a programmatic, reusable way of keeping, first of all, it's also a major reproducibility add-on, right? Because you can almost perfectly replicate what happened with your metric. If you for instance fix the seeds, if you fix a bunch of different moving parts, which you can with AIM, and you can query and rerun the run, etc. So we have lots of these requests to, for instance, build this run lineage, which we're going to build down the line. All of these things are very heavy on reproducibility, and it's ultimately a metadata problem.
So do you think, Gev, the fact that historically you came at this from becoming being so interested in the metadata aspect, do you think that gives you an advantage over other experiment tracking tools?
Well, the thing is that we are not really trying to build this. We're trying to build a way to compare lots of multidimensional data, which experiment tracking is quite a bit. So there is obviously some features like reports type features, etc. But what we are really concerned about tracking lots of these, any type of metadata, intermediate images, and enable the users to build this, not just us, but the users to build these combinable, pieces of, UI, visual, or just, automations on top of this, right? On top of this collected metadata. And this is how
you just happen to have built one of the kind of popular applications on top of it, but other people can do the same.
Oh yeah. And metadata is collected across the pipeline, as far as we are concerned, and may have a different meaning, but it's still a metadata. And nothing restricts people from so basically collecting metadata from all sorts. And we have folks who run AIM on production side of things as well. Not too many, but so.
By the way, this year is a year where we're going to start seeing more and more AI regulations. So obviously metadata will be key to auditing and checking some of these models after the fact, right?
Really, the only way to make sense of the models is collect as much information about them as possible. And for us, the original motivation has always been, if I'm being honest, it has always been the reproducibility and some sort of ethics and understanding I don't want to say the word causality, but understanding why and how things happen. Even though I know these large models are now are a completely different kind of beast. But even, for instance, and we have another project in the working. Even as far as we are concerned, the prompt engineering is another kind of metadata application, right? Because what you do is you're trying to poke your model with some prompts, and so you need to somehow keep track of. It's a little bit different kind of keep track, but it's still you need to understand what have you tried and how it behaved.
Yeah,
So,
and how it behaves, so you can kind of anticipate in the future, right?
oh yeah, and
how
you want to also reproduce your prompts as well in a way. You want to see, oh, what worked, and bring this back, and then let's use this combination, whatever.
Right. And obviously, we're still in the early phases of this kind of prompt interfaces. So, over time, people will build kind of better logging tools for them, right? So, speaking of large models, so what is the largest known model that used AIM?
Oh my God, I don't think I can share that.
Yeah. But there are some large language models that have used AIM.
I believe so.
Yeah. Interesting. And so what's next for you folks? So what's next on the roadmap?
Right. So I think by the time this is released, there should be AIM, either alpha version or stable version of this new major version of AIM, which allows to basically everything you have tracked with AIM, with the APIs that already exist, allows to build lots of UI pieces plus lots of these processing pieces and combine them into this one infrastructure. And we believe that a layer needs to exist on top of the processing, the processing part of the machine learning infrastructure, or the pipeline part of the infrastructure that needs to deal with this metadata. And because the metadata applications are so wide, it's impossible to build them all. And so we want to build this groundwork to deal with the metadata. And this is our roadmap basically for the next.
So you're saying that the AIM will become much more modular?
Big time. Yeah, it's more like a groundwork. So when you want to deal with metadata, two things you don't want to deal with is the dealing with basically the data system, like to make it work, and dealing with the UI, because no ML engineers are great at UI, and no, especially researchers are like not at least the ones we know. And so we want to take care of that and enable a way to combine, basically combine. And yeah.
Oh, so then, are you saying that over time I can pick and choose how much and what part of AIM I would use?
Oh yeah, and that hence in this context it makes sense to integrate AIM with MLflow, because you can use the experiment tracking aspect of it. You can, and we already have folks who are kind of going to build on top of these APIs, but you can even, for instance, add new tabs. Going to be able to add new tabs on top of AIM, like your tab. That's you want, for instance, to see data in a specific way. You can easily add a tab.
So you mentioned these prompt interfaces. So besides that, so what other things are you folks kind of getting interested in ML in general?
Yeah, we are really obsessed about learning, working with the users to see what they're really doing on the ground. So even though there's lots of other, like just obviously the space is so many tools right now, but what we are seeing we working with the users is it's basically, if I try to compare, it's the pre-Kubernetes era of microservices infrastructure, if that makes sense.
Yeah.
And so, and we want to help iron that out as much as possible.
I see. And in terms of combining data types is something I've been interested in, Gev. Multimodal kind of models, but obviously right now it's still quite a bit. A lot of what we talk about tends to be specific data types, right? So like a lot of developments in language models, a lot of developments in computer vision. I think we're starting to see kind of combinations of different data types, right? So like the generative AI stuff, but I would suspect then that metadata becomes even more important in the multimodal world, because now you're tracking text, potentially visual data, potentially audio, right?
Yeah, but the way it works for us, we do not build new stuff for it. We just so the storage underneath is more like an object, a very fast object storage. It's like a Python object storage that can store a ton of these like sequential objects. And if we want to track new type of data, we just extend, or we just define the data. There are like a few primitives, and then voila, you can have a text with images.
So in the data world, when you talk metadata, the applications are what? Data discovery, data governance, data catalog, this kind of thing, right? So now that you have metadata, you can do a lot of that too on the ML side, right? So
I guess if the users decide to use it that way, then it's really fairly on that end. In the lowest level, it's fairly generic. It just stores and allows you to retrieve. So I suppose we haven't looked very deep into that end. We have integrations with the OctiveLoop, DVC, but for relatively basic, tracking the version number, connecting to the say experiment, run to like understand how it came in very deep.
I know MLflow and specifically Databricks have very good offerings in model catalog, model registry world, right? So and obviously you have to be using MLflow to do that, but since you guys are agnostic, you can do that across different tools, right?
Saving models is a little bit of a different beast though, because model sizes are different. So that part we haven't thought much about saving the models.
Oh, I see. So you'll need to cover that at some point if you're going to be the true metadata layer.
I guess you can consider model as a metadata too, right?
Yeah.
In a way. But it's the end result. So
Yeah. So what other things so when you talk to users, so what are some of the common pain points that you're still seeing ML teams grappling with?
So for like ML teams are like obviously different depending on what kind of problem they're solving and the level of compute they have, right?
But what are some of the still common challenges that you keep seeing?
Lots of throwaway scripts connecting the dots, custom dashboards, etc. Hell, it's as I mentioned, as I said, it's the pre-Kubernetes era of microservices. Everybody does their own way. From what we see, there's not a lot of consolidation.
So from your guys' perspective, these scripts are data too, right? Code is
script?
Yeah. No?
These scripts. Can you give an example?
Well, you said there's a lot of throwaway scripts.
Oh, the script. Yeah, maybe. I mean, they can track the script as well. I don't know what they could do with it because the scripts don't change with the pace that the models change with. So I don't know the value of that. For instance, if you change the code for training, sometimes you don't commit. So it makes sense to track the code because it's good for reproducibility. But the script is where we see these are like automation script. For instance, we see users to retrieve some data from some tool and try to do something with it. And then the tool changes a page and they have to change the script. So it's lots of these moving pieces across the whole machine learning pipeline.
A lot of
I guess never thought about script as a metadata though.
A lot of duct tape.
Duct tape, yeah.
That's a good word. Yeah. And what about this whole focus on, so last year people somehow rediscovered the importance of data, so the so-called data-centric AI. So how much tooling do you have to help people who are doing a lot of data work? Yeah,
so basically this data-centric AI movement have led basic, all these integrations with these data tools like DVC, Active Loop. I don't know, there were a few others. Yeah, but this is what has led, everybody was like crazy about, oh, we need to track a lot of data, we need to build a lot of, synthetic data, etc., etc. So which, obviously leads to using these tools. And yeah, that's the kind of wave we got on our end.
And kind of versioning and version control for data almost, right?
Oh yeah. We don't version control data. We consider that as like a problem of its own for us. But we are happy to track the version. Just tell us the version ID and we will track it. That's metadata.
Yeah. And with that, thank you, Gev. And I'll make sure I put links to the things we talked about, AIM itself, including the GitHub repo and this new blog post announcing the integration with MLflow. By the way, last question I forgot to ask you.
Of course.
So if everything is open source, what's the product so that the company becomes sustainable?
Yeah. So AIM is specifically for one user for one project, right?
Okay. So if you want to use AIM as a team, then that becomes that's the commercial product.
You need to subscribe for the commercial product, which is to be launched at some point in the future.
Okay. So right now, AIM is only for a single user, but the value of metadata in a ML team is huge if they can share with each other, right?
Yeah, because in these types of systems, it's not just the researcher; it's the whole ML team. Because there is lots of parts that the MLOps guys want to be part of, and it's one way to collaborate, and it's one way to work together when it comes to metadata. And the researchers, obviously, they're deep into the understanding their models, etc. But how to connect the dots? This is what really motivates us. How to connect the dots between parts of the infrastructure.
This is the most important question, Gev, is when will this product be available?
If I give you a specific date and it doesn't make that wouldn't look nice on my end. So I'd say sometime this year, maybe next year. Really, so we are really focused on the open source, to be honest. Like we want to work with the users. We are learning a lot from the users, and we just want to build so we want to build this best in breed, really well performing. Because with these types of tools, you can just come in and sell an idea, right? It has to work. So we want to first and foremost make it like really the best out there. And then obviously these the rest of the products, will follow.
All right. And with that, thank you, Gev.
Thank you. Appreciate it. It was amazing to chat.